Welcome to today's lesson, which is about dividing in scientific notation. The goals of today's lesson are that you can divide numbers in scientific notation and that you can solve problems using scientific notation. Again, we're going to use the vocabulary coefficient, base, and exponent. So here we're being asked to evaluate the expression, and we've got multiplication here, division here, and multiplication here. So I'm going to rewrite this as like a fraction. So I'm going to say 5.2 times 10 to the negative 4 divided by 3.8 times 10 to the negative 19. And I'm going to separate my coefficients and my base and exponent pairs, and I'm going to do the math separately and then bring it together at the end. So I'm kind of going to draw like a line here. So I'll start off with the coefficients. 5.2 divided by 3.8, and I get, when I divide those, I get 1.368, and I'm going to leave it at that. It's a very long, lot of numbers, and I'm checking this is appropriate for scientific notation because the number is between 1 and 10. And then I'm going to multiply or divide my base and exponent pairs. So I get 10 to the power of negative 4, and when I bring this negative 19, when I divide there, bring it up, that becomes plus 19 when I bring it across the fraction bar. So I get 1.368 by 10 to the power of 15. So here's a problem. We've got the planet Venus has a diameter of 1.21 by 10 to the power of 4 kilometers, and the planet Mercury has a diameter of 4.78 by 10 to the power of 3 kilometers. Which has the greater diameter? And you could think, oh, 4.878 is greater than 1.21, but look at the base and exponent pairs. 10 to the power of 4 is 10,000, and 10 to the power of 3 is only 1,000. So it's much bigger. The 1.21 by 10 to the power of 4 is actually the bigger number. So the planet Venus has the greater diameter, and we can multiply it out, even 1, 2, 1, 0, 0 versus 4,878, and you can see that the 12,000 is much bigger than the 4,800. So then we're asked, how many times as great is the diameter of Venus versus Mercury? So I'm going to say Venus is 1.21 by 10 to the power of 4, and Mercury is 4.878 by 10 to the power of 3. I'm going to divide the diameter of Venus by the diameter of Mercury, like this, and find out how much greater is the diameter of Venus. What do I have to multiply the diameter of Mercury by to get the diameter of Venus? So again, I'm going to split the problem. So I'm going to deal with the coefficients first. And those coefficients, and here I've got the base and exponent pairs. I'm going to deal with them next. So 1.21 divided by 4.878 is 0.248, and a lot more digits, but I'm going to round it there, 0.248. Now that's not suitable for scientific notation because it's not between 1 and 10. So I'm going to move the decimal place to get 2.48. Now what do I have to multiply 2.48 by to get back to 0.248? I'm going to multiply by 10 to the power of -1. And I'm now going to deal with my base and exponent pairs. 10 to the power of 4 divided by 10 to the power of 3. That's 10 to the power of 4 minus 3, which is 10 to the power of 1. And bring that down here. So 10 to the power of 1 times 10 to the power of -1 is 10 to the power of 0, because 1 and -1 is 0. So I'm left with 2.48 by 10 to the power of 0, which is 1. So how many times greater? It is 2.48 times greater. I'm asked to write my answer in a sentence. And I will say, I'm going to write it in green, the diameter of Venus is 2.48 times greater than the diameter of Mercury. So, to summarize, check that the final coefficient is between 1 and 10. Write the units of measure in your solution and look at your solution. Does it make sense? So let's go back and do that. So we said it was Venus was 2.48 times greater. And let's look up here. Does that make sense? So 4,878 is about 5,000, and then 12,100 would say is about 12,000. So if I multiply 5,000 by about 2.5, would I get 12,000? And yes, I would. So the answer does make sense. I wrote my units, 2.4 times greater, and then I wrote a sentence as well. So you saw today how to divide numbers in scientific notation and how to solve problems using scientific notation, and that's the end of today's lesson.